Only 31% of secondary math teachers feel very well prepared to teach statistics when they walk into their classrooms on the first day. So I'm here to give you some resources that'll give you confidence for those first days of classes. We're going to start with Statistics by Freeman, Pisani, and Purves. This is the greatest statistic book ever written for beginners in statistics. If you've not taught statistics before, this is the one you want. It really emphasizes understanding over computation. The explanations are crystal clear, and everything is doled out to you in little bite-sized chunks so that you don't feel overwhelmed. Let me give you a statistical example to show you what I mean. Here we've got the root mean square. Now, where are we in the statistics class? We've talked about averages, we've talked about histograms and plotting the average on the histogram, how the average is kind of the balance point if you weight it down. Notice that everything is done through pictures, through charts, even through cartoons. So we progress to root mean square. You may not have heard of it. The root mean square is a measure of variability around an average. You're going to get this much explanation before you move on to something meaningful. So he gives you a data set and then very clearly spells out what you're supposed to do. Square all of the entries, take the mean, and then take the square root of that mean, the root mean square. Again, it's a very short description before you move on to 6 very intuitive exercises. In fact, this one says no arithmetic is required. So they're really hitting at a high-level conceptual framework. Most important part of these exercises, however, is this line here. The answers to these exercises are on page A49. If I flip back to page A49, we're doing exercise set C. Well, here, exercise set C, page 67. 1, 2, 3, 4, 5, all 6 answers are here. And that's true for the entire book. And that really recommends it. The root mean square is going to show up again. Here it is showing up in the regression chapter because it's fundamental for measuring dispersion around a model, dispersion around a line. It's also going to motivate his description of the standard deviation, which you probably have heard of. But again, notice you've got description, charts, an example, no formula. You've just got exercises to do. All of the answers are in the back. You still haven't computed a standard deviation yet. You will, however, in this next section, which is bite-sized, giving you the formula for a standard deviation and more intuitive exercises. I can't hit the exercises hard enough. What I should also mention are the examples. Depending on how controversial you want to get with your AP statistics class, you will or won't use some of these. For example, the vaccine trial of the Salk polio vaccine. Do you want to talk about vaccines? I don't know, maybe. Also, we've got gender bias in college admissions. Up here, we've got an example of a group called the Samaritans who were trying to prevent suicide death in the United Kingdom. How'd they do? Well, you can find out. This example, the Collins case, is in the probability section, and it describes a time when a man was convicted of robbery because a witness saw a black man with a beard driving a yellow Ford Pinto towards the Empire State Building, and that's the guy right there based on all of those descriptions. Is that enough to convict him? That's what you're going to investigate here. I can't say all the examples are winners. I'm not sure if the Reagan-Mondale election is still on the minds of your children, but it's really in a great section about polling, especially the Gallup poll, which is still around. I just think it's wonderful. I also want to show you that it really has no fluff in it. A very brief section on what an experiment and an observational study are, then right into descriptive statistics, normal distribution, again, straight into correlation and regression. All the descriptive stuff is up front before you move into probability, which talks about chance. Then he combines this idea of variability and chance together to talk about things like expected values. Then we talk about how to sample, and we combine all of that together when we talk about modeling chance and testing significance. You should notice that in this book we talk about the t-test, we talk about the z-test, and we talk about the chi-square test, all three of which are shown in the AP statistics curriculum. There's no fluff here. But it's not all developing concepts to get you to computation. It goes through very, very brief and wonderful explanations of statistical concepts like the regression fallacy, regression to the mean. But it's, again, shown through pictures. Your algebra students will think that because they've got a model describing y in terms of x, that they can do some algebra and get x in terms of y and have something meaningful. Well, that's not true. Here's a section on there are two regression lines. We now move on to the section on probability. He illustrates probability with this very nice sort of model of tickets in a box. I know that seems elementary, but it's going to drive your probability concepts throughout the rest of this book. And it's going to show up again. You're going to get all the way through the book and wind up here on the chi-square test towards the end. It's explained through that same simple box and tickets model. You cannot go wrong when using this book. My next recommendation is Naked Statistics by Charles Freeman. You'll notice that this isn't a textbook. It's a pop math book, a New York Times bestseller, in fact. But what you're going to get from this is everyday language discussions of very big topics that you cover in statistics. For example, when you talk about correlation, he drives his discussion by asking, how does Netflix know what movies I like? When he talks about probability, he asks if I should get the extended warranty on your next printer. Here we've got a discussion of DNA's use in courtrooms. This example I happen to love. If you have a blood test for a very rare disease and it comes back positive, what are the chances you actually have the disease? The answer is not what you think, and he gives a beautiful discussion of how that works. Big statistical topics are also covered in this book. Here he talks about robustness, median and mean kind of things. Here he discusses school quality. If you want to measure the quality of a school, what should you measure? Is it tests? Is it teacher ratings? Is it surveys? Is it growth? Are you measuring what you think you measure? And that's a big question. But I don't want you to think that the math is left out of this book. It is absolutely here. Here he's got an entire chapter on what he calls the LeBron James of statistics, the central limit theorem. Now, why LeBron James? Because the central limit theorem is really the powerhouse of the team of statistics that you're going to learn in the year. The central limit theorem sort of drives everything else. In his chapter on regression, he does give a tiny little bit on the t-distribution. It's tiny, but it's relevant. You'll notice it's done through pictures, and there's just not much of it, but it's all you need. I like especially the chapter on 5 questions that statistics can help answer, because it's not always obvious. For example, what is the future of football? You know, they've got chronic traumatic encephalopathy these days, and they're studying it. What does that mean for the sport that every American likes? What, if anything, is causing the dramatic rise in the incidence of autism? How can we identify and reward good teachers in schools? What are the best tools for fighting global poverty? I just think, who gets to know what about you? Privacy. You're just not going to do any better than this for a breezy, quick, but deep read of the stuff you're going to be teaching. Next up, I have Workshop Statistics by Alan Rossman and Beth Chance. This is the 2nd edition. There are 3rd and 4th editions. Any one of them will serve you well. Get the one you can get. What I want to show you is that this is a blueprint for active activities in your statistics class. Let me just flip over to the regression chapter and show you what I mean. Here's where they are introducing least squares. You're going to get classroom-ready stuff. Here's the questions, here's the space to answer them, here's the activities, here's the data. It is all laid out for you. There's going to be maybe a little explanation in the middle of it, but it could not be more classroom ready, and there couldn't be a wider variety of activities for you to do. Let's look at the list. Word lengths, penny thoughts, parents' ages, gender of physicians, Supreme Court service, birth and death rates, college tuitions. Look how many you have available to you for your statistics class. It's incredible. You should also go to the website of these two people, Rossman and Chance. There's a website listed in this book, but I don't think it's right. Let's see. Key College Press is no longer with us. The correct place you want to go is rossmanchance.com. Especially go to rossmanchance.com/applets. They've got an amazing array of statistical applets for you to look at and use in your demonstrations. Really, this is like a gift. This is like an experienced statistics teacher handing you sheets as you need them. Final recommendation, also a little strange, The Curious Cook by Harold McGee. Now, this book has nothing to do with statistics. Why am I recommending it to you? Well, I want to inspire you into thinking statistically when you're doing other things. I happen to cook a lot. This is a book on what he calls kitchen lore. There are certain legends in cooking that you hear repeated a lot. For example, chapter 1, the searing truth. I've heard all my life, you have to sear your meat to seal in the juices. Well, does it seal in the juices? Is that what searing does? First of all, does it do that? And second of all, is that why you do it? Well, it's kind of laid out here. Again, it's not a statistics book, but he absolutely tells you how he went about answering the question. He used a digital scale designed for letters and small packages. Instead of stakes, he used a cheap cut. He cut it into 1-inch pieces, stuck a thermometer in, weighed them before and after. Second question, why does guacamole turn brown? When you make guacamole, they often tell you to put the avocado pit in the guacamole to keep it green. Does it work? He shows you exactly how he went through his experiment to answer that question. And finally, I've always wondered this myself. People tell you never to wash mushrooms. Should you brush them off? How do you clean them? Because they grow in the dirt. He goes through a discussion and shows you how he came to a conclusion, which I won't spoil for you. Now, do you actually need this specific book? I don't think so. My point is, statistics is everywhere, and you can get inspiration from anywhere, including a cookbook. Ask around. Find things in your house that are numerical. I've got a guitar over there. The frets are not all the same distance apart. Can I predict how far apart the frets are going to be based on the distance from the sound hole? Maybe. There's numbers everywhere. You're learning statistics because it is a service discipline. It is there to help you find truth. Look for truth in everything you can. Look for questions in anything you read. So those are my recommendations. You've got this. Statistics is just a state of mind. Just bear in mind, you're not teaching recipes to your students. You're not teaching formulas. You're not teaching a flow chart of things to go through. You are teaching how to think like a statistician. You will get there.